Well, welcome everybody back. It looks as if the carnivores and the vegetarian vegan lines were well behaved. There didn't seem to be any skirmishes between the two lines. That's an excellent sort of forebode of how the afternoon is going to go. I was delighted when Jim asked Stefan and me to come and talk at lunchtime. It's a really fun forum in which to sort of have a conversation, and that's what we're going to do. Stefan and I got reconnected this fall when he was in the final throes of finishing this book, Resource Revolution, which is, I was really, really excited. He and his colleague, Matt Rogers, who's a close friend of mine, have put this together, and I got to read some early drafts, and I thought, oh my goodness, we do have a common sense of purpose. Stefan has spent 18 years at McKinsey as a management consultant. I have spent time both as an investor and in government policy. Even though those backgrounds and our educational backgrounds are quite different, we share a common sense of the opportunities and purpose in using resources better. So what we're going to do a little bit today is focus on some of the content of the book and then pivot it into some of the issues that are of interest to this group in this conference. We will take a lot of questions at the end, so please get ready. We actually like fiery questions, so please, anything is fair game. The same deal that there will be 3 students around the room who will give you a mic, say your name and your affiliation, and then we'll go. So. Great book. It was, I think when it first came out, it was on book stands in New York City. I think you saw it at Grand Central Station right next to Flash Boys, which is it was a very good placement for Stefan. But tell us, Stefan, why did you and Matt decide to write this book?
Yeah, Matt was in the Department of Energy with you at that time when he was beginning to see patterns among the companies that he was funding through the stimulus funding. And over again, people were underestimating how quickly these technologies were actually moving. And I saw the same in the large companies I was working with, where they would plan their business based on historical costs and look at what the future would bring, and whether that's transportation or energy or the built environment, and basically assume that you would have modest innovation, modest technology change along the way. And over again, when you actually looked at the rate of progress, the learning curves were much faster than that. And what we found is businesses that should have seen the technology coming, the new technology evolving, because the data was all there, kept getting surprised. And so the book really grew out of that sense of we want to crystallize these insights and talk about what is this underlying resource pressure that's causing this level of innovation. And what's the set of technologies that offer that promise of another industrial revolution at the same scale as the previous industrial revolutions that we've seen that have a step change in productivity? And how do you incorporate those? And that's why we called it the biggest business opportunity. How do you incorporate those into what you're doing, whether you're a regulator making policy, whether you're a business trying to attack an existing market, or somebody trying to create a new market around what the new technologies enable. So this is really kind of a distillation of about a decade of wrestling with this in practice and trying to make it easier for the next person wrestling with it to be able to grapple with this.
What I found so interesting is that it's not just about energy or just about water. I mean, you don't even have the book divided up in those sorts of chapters. I mean, tell us a little bit about that. These are common themes. What are the key elements of this wave of innovation?
Well, the root of it really is that we're going from 1.5 billion in developed world population that lives a middle-class life to adding another 2.5 billion. The majority of that is India and China, but it actually spreads broadly across developing countries. In fact, if you look at the GDP growth rate of Africa, it is now equal to the GDP growth rate of China, obviously from a lower base, but the rate of growth is the same. And it's those 2.5 billion that are starting to buy cars, live in fancier apartment buildings and homes, begin to eat meat the way that we all just did.
Some of us did.
That's right. And consume energy, water, food, and all of the input material resources, minerals, metals, at the same rate that we do. And if you just forward that trajectory, if they do it exactly the same way that we do and we don't change our ways, we get incredible resource pressures globally. Matt and I looked very carefully at would we run out of anything, because that has obviously been a meme in popular culture for a long time, whether it's Malthus talking about running out of food or the Club of Rome talking about running out of oil. And we couldn't find anything that we would really run out of. But in a way, that's the wrong problem to focus on. The issue really is we have already seen, and we'll see more, dramatic price increases, because if you have 2.5 billion more in demand, at the same time that the easy stuff has already all been collected. You know, we used to find gold nuggets on the ground not that far from here, and now you have to go deep underground, further offshore in the case of oil, under salt formation. So it gets very expensive to get the minerals that are still there, but to be able to get them into human use. And it's that phenomenon. And the second thing that's happened is, as we've globalized, more of these materials have substituted for one another. So that's why it's no longer just an energy problem or just a water problem. We use a lot of water to generate energy. We use a lot of water in mining to process minerals. We use a lot of steel in the energy system for energy production and for energy distribution. And so there are these deep linkages. And if you went to a financial advisor in the 1980s, you would have been told classic portfolio theory, well, you should have some money in stocks, some money in bonds, some money in commodities. And the commodities provide a lot of diversification because they're uncorrelated with each other. In fact, at that time, some of them were negatively correlated. So as one goes up, another one goes down. If you look at the data from the last decade, it's all basically energy related. It's all linked to oil in one form or another because we use natural gas as input for fertilizer, so it's in food. We use diesel fuel for every kind of mining operation on the planet. So the risk is actually magnified that way. And that's why it really is a resource problem holistically, because you can't tackle just a water issue or just a food issue. And you also can't tackle it just in one region, because we have, for most of these commodities, we have global markets and global trade flows. So it's become a much more complicated problem to solve and a much more urgent problem to solve, given the scale that we're talking about.
You do characterize this as kind of the third innovation wave. I mean, tell our colleagues here about what was the first wave and what happened to global economics. What was the second wave? What happened to global economics? And now, because it gives you a sense, I think, of your view about where we could be headed.
Well, we forget how dramatically different our life is from 4 or 5 generations ago. Even our great-grandparents had very different lives. So the first industrial revolution began earliest in England, somewhere in the 1730s to 1770s, depending on what you take as the exact starting point. And what's important to realize is life expectancy was in the high 30s, right? So people lived half as long as we do now. And for the entire period since the Roman civilization, we had almost doubled GDP globally. And that's it, right? So in 1,700 years, we doubled. If you look at the next 50 years, we can quintuple GDP, and life expectancy started shooting up, not quite to the level we have today, but actually most of that increase came very early on. So that's a complete transformation. And we went from having about 2,000 calories of energy available to most people, which is basically what they ate, and a little bit of horsepower, donkey power, whatever it might have been, water power, to having 200,000. So it's a 2 orders of magnitude increase in the energy that each of us has available for work, for maintaining the comfortable environment in our homes and offices. And it's that step change that really characterizes an industrial revolution. We've seen the same again in the time of our great-grandparents, which is between 1880 and 1920 roughly, when most of the developed countries moved to cities. We stopped being farmers, and the majority of the population took industrial or service jobs. We started using steel in very large quantities for railroads, for cars, for trains, for skyscrapers. And the productivity went up again because we had these cities that became very vibrant cultural centers and economic centers. And the amount of commerce we could have dramatically increased. So if you were born before the advent of railroads, a New York to Chicago trip took 6 weeks and cost you about 30 cents per ton mile if you're moving goods, because you were doing it over wagon trains. And so most trade at that point in time was limited to about 50 miles radius. You didn't really interact with somebody who was much more than that. If you came to California, that was a once-in-a-lifetime journey, right? You weren't going back for the weekend or anything like that. You look at, with railroads and cars, the cost dropped to less than a penny per ton mile. New York to Chicago was less than a 2-day journey. And of course, now we fly, so it's an hour journey if we don't have thunderstorms or air traffic problems. And our commerce now is global, right? There's really no limit. I mean, you go to even remote parts of the world, Papua New Guinea, and you can actually find Western industrialized products, right? You can get Coca-Cola.
Get a Coca-Cola everywhere.
Yeah, exactly. So that's the second big shift. And our argument is that we're already into the beginning of the next big shift like that. There is a difference, though. The previous shifts were really dramatic upshifts in labor productivity, right? We mechanized and automated farm production, industrial production. We built factories. We started assembly lines. And so the output per labor hour dramatically increased. And we've moved quite a lot on that dimension. Labor productivity is about 100-fold what it used to be 150 years ago. And we continued to do that in the last couple decades, right? All the offshoring, outsourcing, taking advantage of a global trade really was a form of increasing labor productivity. If you look at it from a resource lens, though, what output am I getting in GDP and wealth, in revenue, per material inputs, whether that's land, water, oil, steel that you're consuming, whatever your business happens to be, we've moved a little bit. It's about a 3-fold increase in productivity. So 100-fold productivity improvement on labor versus about a 3-fold on other resources. So there's still the same massive potential to increase resource productivity. And that's the core thesis of this next revolution. And the reason I say we're already into it is the models are all around us. Whether it's taking cars and making them electric, whether it's distributing our energy system to produce locally and not having to have all those losses in the transmission system, whether it's increasing our asset utilization. Every time you use Airbnb, you're increasing the productivity of that residential asset, right? You're increasing the utilization of that room space. And same thing for a lot of our online booking. The reason airlines are profitable now is not because they discovered some new fuel that's cheaper. In fact, fuel prices have still gone up, but they're using a lot less fuel from more efficient engines, and they're loading the planes more through online booking and capacity management. So in the fundamentals, this is another revolution the same way, a step change in productivity, but in the details, it's quite different. And it's a neglected dimension. Most companies, if you talk to them and you said, what's your energy productivity, what's your water productivity, how much revenue are you generating per ton of metal that you use? Most companies have no idea. It's not measured. It's not taught in business school by and large, right? They're looking at their balance sheet, capital productivity, and they're looking at labor and employee productivity. We've not focused as much. There are a few exceptions. If you're in the mining business, you're thinking about how much output you're getting out because that's all you do. But most companies across the economy really haven't focused on this resource dimension. And that's why there's this massive latent opportunity that's all around us.
But the potential that I'm seeing, so I was trained as a geologist and an engineer, and I've spent all of my career in the resource area, but much of it in energy. And as a young geologist, all we knew how to do was punch holes straight down. And we got a lot of dry ones, and it was expensive. And I thought, and that's when, I mean, it was 1982, I said, there's got to be a better way. There's got to be a different sort of energy future that's not, where the resources don't run out and they don't get more expensive and more scarce. I'm seeing what you're seeing on the back of a couple of major things that are enabling better use of resources. Why don't you talk about the 2 platforms that we uncovered and that we're writing a lot about and doing a lot of research about?
Yeah, so, I mean, the one you alluded to in the geology is shale gas, right? We've learned how to drill horizontally. We've learned how to use computer software to have a look before you go drill a well and do very complicated 3D seismic. But one of the biggest areas that Cathy and I have been working on is transportation. And if you look at the current transportation system, you know, it's a mature industry, right? It's growing roughly with GDP. We have a few major companies globally that are dominating the auto industry. And it's not like we're reinventing how roads are built. Yeah, we widen the highways and add another lane, but we're not really rethinking our transport system. And where's that productivity at? Well, let's look at all of you. How many of you own a car? Show of hands. Most of you. And
how many don't own a car?
all right, that's probably a better sample size. A few. Okay, excellent. If this were New York, it'd be a little bit different balance. But so for those of you who own a car, where is it now? Parked. That's right. That's right. And just by sort of dimension of your hands, from I'm in the car most of the time to I only drive it a little bit. What percentage of the time are you in your car? Yeah, a few of you are long-distance commuters, but mostly very small. The average across the entire economy is 4%. So imagine if I said, Your second biggest investment that you're going to make in your life, if you don't own a jet or a vacation home or a yacht, your second biggest investment, your car, you're going to get 4% asset utilization. If that came from a banker, you'd be like, I need a different financial advisor, right? This doesn't make any sense. And then people say, well, maybe it's peak usage, right? At rush hour, we're all in our cars. Well, actually, the statistics are at rush hour, 15% of cars are actually being driven. So 85% are still parked. And by the way, of the 4% that you're in your car, roughly half of that you're either looking for parking or stuck in congestion. So 2% you're really going from A to B. Then let's look at the rest of the system, right? If you look at the fuel use, Amory Lovins did this analysis famously in the 70s, less than 1% of the fuel you pump, you know, for that $55 refill of your tank, less than 1% really goes to moving you from A to B, right? So $54.8 you're burning up in friction, in extra maintenance costs, because you got tire wear, brake wear, all this other stuff that you're actually grinding down, and in air resistance and in stop and go losses. Then if you look at the people in the car, we accept $300 billion in damage and lost productivity every year from car accidents, and 33,000 deaths in the US alone. And by the way, we're better than the rest of the world. It's about the 13th leading cause of death in the US. It's about 9th leading cause globally, and there's millions of deaths from automobile traffic on a global basis. Why does it have to be that way? We fly our planes and most of our machinery and our boats all automatically with autopilot, and yet we rely on human drivers, where 85% of human drivers think they're better than average drivers. So, what a weird system. And then the worst part, back to the roads. If you do the math on roads, we spend 1.7% of GDP on building roads. Quite a lot. We could fund a lot of healthcare and schools with that amount of money. And what do we do with that? Well, if you measure a road at peak utilization, during rush hour when it's not a traffic jam, if traffic's actually flowing, you get about 2,000 cars per lane per hour. That's sort of peak. If you jam any more cars in there, actually the throughput drops because you get a traffic jam. And if you then look at how much of the road is actually carrying cars at that point, it's less than 10%. There's a lot of space between cars, right, to be driving safely. And that happens only for an hour or two, one direction, 5 days a week. So you're talking about 0.1% utilization of 1.7% of our GDP. That's what I'm talking about with, we haven't taken the lens of resources and said, does this system make sense, and could we make it more productive?
So with transportation, because everybody feels that personally, and when you're in Northern California, it's hard to not rely on a car some of the time. What's the systemic, or the set of systemic changes to make it better, to sort of tap into the potential of the resource revolution?
So every part of that, as you know from the work we've been doing with students, can shift dramatically. You can take the 1% that's used of the fuel and turn the car electric. Battery plus electric motors about 85% efficient round trip. So that's a massive improvement. You can take the 15% peak utilization, 4% average utilization, and share the car fleet. If you look at Zipcar or Uber or any of these systems, they get about 60% utilization of the fleet.
Just sidebar comment, and again, for those of you who have grown kids like I do, we gave each of our kids who are 20-somethings an old Prius to drive when they graduated from college. They both moved into San Francisco, and they both recently, in the past month, said, you know, we don't want the cars anymore. And I said, what are you going to do? They said, well, we're going to use Uber, we're going to use Zipcar, and well, my son's going to use his girlfriend's car, which is not quite fair. But, but the point is that it's the social norms seem to be changing. You know, the kids, you know, as the story goes, they care more about like the mobile phone they carry and the case that it's in, and these are than having the car. The car is inconvenient, and so there's a combination of technology and public policy that's changing something pretty dramatically from when I was in my 20s.
And it's a big expense item. On average, for a typical American household, it's about $50,000 in spending power, and 17% of that goes to the car. Right. So if you're a 25-year-old starting out, it's a significant expense.
There's a couple of macro things that are happening there that are driving this potential in the transportation to have a revolution. One of them is IT. So let's talk a little bit about how the IT revolution is enabling. We're doing things with IT that we couldn't have done 10 years ago.
Yeah, in fact, the cusp of the biggest one in transportation we're seeing in the Google autonomous car, which now all the car companies have woken up and are trying to replicate, because then you're dramatically increasing the fuel efficiency of how the car drives. You're reducing those accidents. About 90% of all the accidents are actually human-caused. So we wouldn't solve every accident, but we'd get rid of most of them. And we now have a network-connected car that can actually coordinate with the other cars. So you can do drafting and like a peloton in a bike race. That improves fuel efficiency. You can schedule the cars. I could literally just call a car up on my phone the way I do with Uber now, but the car would show up without a driver, right? And the car would recharge itself when it's not in use or go find the next passenger, so we could shrink the parking space. Because of the proximity of the cars, you can take a 4-lane highway, take 101 out here, and turn it into the equivalent from carrying capacity of a 32-lane highway. So we'd be done building roads. We'd just be patching the ones we have. All of that is enabled by this amazing processing power, right? When Google first built its car, it's about $100,000 to install the LiDAR and all the computing power to be able to drive autonomously. And the roadmap that our students developed says that we're about at $2,500 in a year, and we're going to go to a couple $100 2 or 3 years from now. That is an amazing.
Yeah, it echoes. I mean, Steve Chu talked a lot about learning curves. Almost all of the work that Stefan and I do together relies on really good, sophisticated analysis of what the learning rates are going to be. And the other thing is that what we've seen in the past sort of decade or so is that we've gone much faster than many people would have predicted on a lot of these innovation developments. One other area I think that is worth talking about is why we're able to sort of get such huge fuel economy improvements has to do with materials.
That's right.
So maybe talk a little bit about.
Yeah, materials are cropping up everywhere in the economy now. A lot of them custom engineered using very precise knowledge of material science, or even down to the nano scale of how am I assembling the material. And whether that's a ceramic or the carbon fiber that's in everything from golf clubs to wind turbines now, to increasingly also in cars. The new BMW that's super fuel efficient is an all carbon fiber body. And that, again, it changes how much material you need to get the performance you need. You actually, in many cases, not only get a material reduction, but a performance increase. So I get a double win because I'm using less energy, water, material, and I'm also getting more performance out, right? The Tesla is actually a really high-performance car, faster acceleration, better safety standards on the backs of actually making it lighter and more fuel efficient. But Cathy, you should also talk a little bit about the rest of the digital impact that we've seen on the economy.
Well, I mean, again, let's just ask some questions of the audience. How many people do some of their banking online now? Okay. What about e-commerce? You buy things from Amazon? Anybody who doesn't buy something from Amazon? Yeah. Again, that's the standout. Grocery shopping? Grocery delivery? Yeah, okay. Not as common. Yeah. How about telecommuting? How many people telecommute at least some of the time? How many people would like to telecommute some of the time, but they work for Yahoo and they're not allowed? I'm sorry. That was a nasty comment. What about streaming movies at home rather than going to the theaters? So all of these things are happening now. Oh, here's another one. How about, do you ever go to WebMD now instead of going to the doctor? Right? It's actually pretty good information, right? So one of the things that we were doing is we did a research seminar this winter on emerging innovations that are potentially highly disruptive that might have a positive impact on greenhouse gas emissions. So we looked at a lot of things, and this is one of the areas that we tried to quantify, and there's not much data out there, but our graduate student was fabulous, and so she came up with a bunch. She said, well, banking right now, on average, people go to the bank 24 times a year. With online banking, we could take it down to 4 by 2025. Groceries, most people go to the grocery store nearly twice a week. What if we increase that 13% a year, and so by 2025, 12% of our grocery shopping was done online. Retail, right now about 7% of e-commerce, 7% of retail is done virtually. What if we doubled that by 2025? What if we took our visits to the doctor, if we're the healthy people, not the really sick people, but the healthy part of the population, instead of going to the doctor 5 times a year, only to cut that in half? And what if everybody who's in an industry that it's possible to telecommuted 2 days a week? What would that add up to? Turns out that in those sectors, that would reduce greenhouse gas emissions nearly 30%. That's pretty astonishing, right? And there's also ancillary benefits that come with the comfort, lifestyle, quality of life, productivity, and everything else. So this is just scratch the surface sort of data analysis. I mean, Stefan and I have yacked about who could really help us with very good estimates of this. And you know who could? It would be the guys that have your iPhone and your GPS, because they know exactly where you are all the time, and we can figure it out with real data. But the point is, this is something that's happening that nobody thinks about in terms of an emissions reduction strategy. But we might want to make sure that leaders in businesses and government agencies know that there's a benefit. I mean, if we never had to go to the DMV again because we could do everything online, there would be a lot of benefits to that. So this is just one of the things that we're uncovering a little bit. So this innovation that's happening with materials, with IT, they say that necessity is the mother of invention. Do you feel, Stefan, that this wave of innovation is being driven by necessity?
I think necessity is giving this a big push. I mean, we look at the past industrial revolutions, it was always with dire predictions of overcrowding, running out of food, and I think we have a bit of the same now. We have price spikes that force people to innovate, because many companies can't actually afford those higher prices in many parts of the world. People actually are rioting over the cost of food increasing. I don't think it's only necessity. I think there's a lot of ingenuity, a lot of creativity, a lot of entrepreneurial spirit that's going into making some of these new models happen.
Okay, I mean, somebody like Elon Musk, is he driven by necessity? Is he driven by money? Is he driven by the pursuit of genius and what can be? Yes, right.
By vision. So they're clearly, I mean, we're in the locus of people trying to change the world around these dimensions. So I think that is the motivator for the origination of a lot of these ideas. The scaling, I do think necessity plays a big role. And then the other part is what you spent most of your working career on, which is how do you get governments to clear the roadblocks to actually allow this to scale. And some of that is incentives for things that are still emergent, where the cost is initially still high and you have to go down the learning curve. But a lot of that's also just clearing away barriers, because the way things were codified into law or into regulation didn't even contemplate the new technology, right? So whether it's Tesla fighting the current dealer structure, because you all love your car dealers and going to them, right? Or whether that's Uber running into taxi commissions because we like having these really constrained number of cars in all our major cities so that you can never find a cab at 5 in the afternoon. I find it fascinating. I spent a couple of years living in New York. The turnover between the shifts in drivers is between 5 and 6 p.m. Whoever designed that system, right? They're all going home to Brooklyn exactly at the time when everybody else wants to go home to work. But that's the structure we have today, and a lot of the new models are running into that. And so there's as much clearing of old regulatory structures as there is actual support for the new.
The two areas that we're thinking a lot about today are energy and water. So let's talk a little bit about how IT, new materials, and the third wave of innovation are creating exciting opportunities from your perspective. Let's start with energy.
Yeah, so energy, I mean, the biggest innovation there is we've taken Moore's law and applied it into the same material set, silicon, but applied it into the energy world. And so we've seen dramatic reductions in the cost of solar. Used to be 22 times as expensive in the grid when Carter put panels on the White House, to now we're at about grid parity in about a third of the US. It's about 70 countries worldwide. And that number will increase to the majority of countries by the end of this decade. So we're talking about just a couple of years. We've seen wind power already come down to the point where wind power in states that have high wind is already competitive with fossil fuel power. And what's even more interesting, I found from the work we've done together, is the slopes are actually opposite. If you look at nuclear and coal power plants, not only are they not going down as fast, their cost is actually going up over time. So we're talking about a set of technologies that's green, that's continuing to be reduced in cost, while at the same time fossil technologies are going up. And the input to fossil technologies, the fuel, is also going up because of these increase in demand and the increase in capital to develop the fuel sources. So it's an exciting time. There's a second dimension to it, which is actually changing the way the grid is architected, right? We built everything based on streetcars and street lights originally when we first built power stations, all in a kind of radial pattern out from a central power station. That made sense at the time when, you know, when Edison first put in light bulbs. They were $25 a piece. They lasted for 4 or 5 hours, and you were paying $8 a kilowatt hour for your electricity. So light bulbs were pretty precious back then. Now, actually, we want them in all of our homes, and we take them for granted. So the ability to re-architect our energy system to make it much more resilient, much more decentralized, much lower losses, and to balance it in real time, much like we do our internet or our phone system, rather than to balance it by just cranking in more supply, which is what we do today, right? Somewhere between 3 and 6% of power is just to ensure stability of the voltage, and whenever anybody flips on a motor or a light switch, that power is there. But that's really wasted energy 24/7 across the entire economy. That's a huge amount of power that structurally we've designed to waste in the current system.
Staying on energy for a second, we have also seen similar opportunities with buildings, both in, you know, putting better technologies in existing building stocks that are being driven on, again, digital lighting, LEDs. I think there was a session this morning that was focused on lighting, better air conditioning, windows that use new materials so that they're photosensitive, all of that. But one great example that Stefan talks about in the book is a Chinese company that's building skyscrapers in a few weeks. So why don't you? That's a great story.
It's a company called Broad Sustainable Building, Zhangsha in Chinese. And they've essentially designed a super efficient modular building. Everything is factory built. They use the floorboards of, they build, it's Chinese building, so it's mostly taller, bigger than here, 10, 15, 30 stories. And the floor panels wind up being the pallet. All of the wall panels and all of the interiors get stacked on that. All the plumbing, wiring, control systems, air conditioning, everything's already built into the factory. So literally the whole set gets lifted up at the next level that you're building on the skyscraper. The vertical elements get tilted up and bolted in. And they can literally build a 30-story building in 15 days. And this is not a cheap building, right? This is a high-end luxury apartment building that has all of the convenience features, appliances that we would like and take for granted. And the best part is, because it's built in a factory environment, it doesn't have the 30% waste that we always have when we do custom stick-built buildings, right? A third of what you bring to a construction site gets sawed off or cut off, or somebody makes a mistake and it gets right into the dumpster. In a factory environment, you can have zero waste, just like most of our other factories do. So it's a dramatic productivity improvement. It also changes the time, and so your capital cost of how long you have to wait to move in is completely different. The error rate is completely different. Honda actually builds homes in Japan this way, with a factory process. And any of you who've ever remodeled will appreciate this. They deliver the home, turn over the keys to you within a 4-hour window that they give you at the beginning of the project, with 1 defect per house on average. So your punch list is 1 item long. You don't have to make a list. So that's the kind of opportunity we're talking about. And really, what it means is, from the demand side, from these energy efficiency measures, we've already seen peak oil demand in the US, right? Peak gasoline demand happened somewhere in 2006 before the recession. And our CAFE standards are driving the consumption down, even though we continue to drive the same way. And the same thing we're going to see now in electricity demand because of solar coming in, energy efficiency in buildings, lighting. Midwest ISO was the first region to now announce that they expect 1% drop in electricity demand in the medium and long term. And I think 1% is still too much of a projection from yesteryear. We're actually going to see much more decline than that with all those technologies coming in.
Let's do a little on water, because we've got a lot of folks in the audience that are interested in water. Where are we seeing gigantic innovation potential in the water arena?
Well, I think water is an example where it has been driven in areas by necessity. So the 2 biggest sources of innovation for water have been Israel and Singapore. And you know, Singapore is an island with very little water. They rely on a neighbor, Malaysia, for water, and it's a strategic vulnerability. And for Israel, they're trying to grow in the middle of a desert, not a place you'd naturally put agriculture or cities. And so if you look at Singapore, they've moved to a closed-loop water system with a lot of filtration and efficiency measures. Israel, water circulates through the economy roughly 3.5 times before it's used up. Most of our water here is, even though we have drought conditions in California, is still once through our economy. And it's a range of technologies, right? It's from the things that you're used to it in your home, from low-flow faucet to instant water heaters to drip irrigation systems. That's been one of the biggest innovations coming out of Israel, is Netafim, and very precise control systems so that you're sensing the moisture of the soil and only adding as much water as needed and adding it directly to the plant. And then also beginning to change the plants so that we breed them for hardiness so they can actually survive in a drier climate.
So California, we're all aware of the intense drought that we're experiencing. And so the question then is, you've got this opportunity for this innovation. Will it happen on its own? Does it require interventions by policymakers? I mean, what's your experience? You see all of this potential. You're a business guy, so you're pitching this to business guys. Do they listen? Do they seize the opportunity? Or do they need to be directed by policymakers?
Well, water's an interesting example. Where it has been directly businesses, we've seen a lot of uptake of these new technologies. So if you look at the semiconductor industry, it used to be a big consumer of water in the 1970s. And every semiconductor plant now is closed loop on water. And that's
why?
Well, they've done it because it saves money, and in that case, it was a corporate decision maker. It was the facility plant manager that could decide, and they get an extra benefit in that case because purity matters a lot to the manufacturing process. So any contamination of the water destroys your microprocessors or memory chips or whatever you happen to be making. So there's a real business value that's tangible just above the cost of the water consumption reduction. If you look at the rest of our system, though, I think it does require government intervention because most of the water infrastructure is in the hands of municipalities who are structurally, financially weak in this country, right? Underfunded, and many of them leveraged quite a bit, and so don't have the capital required to make these upgrades initially, even though they would save money on an operating basis. We also underprice water. Water really should be about 4 times the price if you look at the economic supply-demand balance. The entire western half of the U.S. is short of water. So, and then our legal infrastructure is based on priority of claim when there was nobody in the West. And so we have a lot of claims from 150, 200 years ago that has nothing to do with the value of that water today or really the...
With this one, I mean, we heard warnings from Ralph Cavanagh about the market can't solve everything, as we witnessed when we totally deregulated the California electricity market. If we effectively could politically raise the price of water 4x to reflect what it actually costs, would that do it?
I think we still have to solve distribution and priority claims. And you can talk about this. Australia has done quite interesting innovations in terms of water pricing and water market mechanisms that have actually helped shift demand and displaced some.
Well, in Australia, I mean, again, because the drought, I lived in Australia for 12 years. We were experiencing such a prolonged drought for such a long time before it even took hold here in California. It was a multifaceted approach. So prices did go up, education programs were really strong, and we added a desalination plant that was fueled by renewables. And I was on that Metropolitan Water Commission study to make sure that we weren't actually exacerbating greenhouse gas problems as we were trying to solve a water problem. And it turns out that even with a desalination plant fueled with renewables, it has had a de minimis impact on consumer prices like water bills in a way that was terribly harmful. Yeah. So it actually ended up all right.
I find it very interesting. There's a solar company that's built solar panels over a canal in India. And it's a great sort of multiple win kind of project because you get less evaporation from the water going through the canal. You generate solar power in a rural community that's short of power. You have essentially no cost to the land because it's already an infrastructure project and you're just adding it on top. My first question was, well, why don't we do that with our aqueduct here in California, right? We actually lose a huge percentage of the water before it gets to LA just from evaporation.
I think we're going to pause with our conversation and give you guys an opportunity to ask questions. Again, this is a Renaissance man on the stage. He'll talk to anything. We've got material, circularity, transport, electricity, whatever you've got in mind. It is fair game for Dr. Heck over here. So where are our microphones?
I can't see anything.
Yeah. Okay. Questions for Stefan?
Or for Cathy?
Yes, over here. Please say your name and your affiliation for us. I think I need sunglasses for these spotlights, you guys.
Hi, my name's Sophia Lynn, and I'm with the USDA Forest Service. And my question's about your proposal for marking up water to more correctly represent its value. But what would your response be to the fact that water is considered by many areas of the world as a more basic human right, and that it shouldn't even be privatized in the first place? And if it is, some argue that those who do exploit water for, extra uses will still be able to pay those higher costs, while conversely, those who need it for just the most basic needs will not be able to pay those higher prices of water.
Yeah, and I was talking about the average price, to be clear. I don't think you should have a flat structure where everybody pays the same price. We don't do that for all our other utilities as well. So I think there is a big social equity component. In a lot of countries, part of the reason water is underpriced has been that we had a set of subsidies for either farming activities or cities at the origin, and now we have more industrial uses, or we also have new crops that people are growing. And I think Australia was an example of that, right? Part of what was displaced was things that you shouldn't have been growing in an arid climate in the first place. But
we were growing rice in the desert.
Rice in the desert, yeah, not a good idea. But I think your basic point I completely agree with, right? We do have to take into account the social equity, and the average price going up doesn't mean that we should make water be unaffordable for lower income households and people that. And
you would know this, but we do in electricity is there's a basic lifeline rate for, for householders, so that everybody can get electricity at low price.
Well, we do it in phones, we do it,
an inclining block structure is what they call in the electricity world.
Yeah.
Yes. Sorry.
Hi, Cathy and Stefan. It's Hunter from the class. I have a question on solar roadways. So we're talking about efficiency in the transportation sector and utilizing land that has already been built. So I watched a video a couple days ago on this new technology where it's literally a road made of solar panels, and they're really hard plastic, so they withstand the weight of multiple vehicles. And actually, they have heating within the material, so when it snows, it will heat the road, so you don't have to clean up the snow, and it's got sensors to track all the the vehicles and everything. I don't know, maybe just talk about the viability of something like that and the potential benefits.
Yeah, I love that video, by the way, and it's actually glass, not plastic, that they built it out of, because glass is stronger, as you all now know, given that you all carry a piece of glass in your pocket. As a technologist, I love what they've done, right? They've integrated a whole bunch of technologies from LED to solar to structural properties to the bumps on the surface so you've got traction, and I think it's brilliant. As a business person, I think it's a really difficult proposition, and I'll tell you why. Because yes, if you aggregate all the things that those road panels do, and you compare that to the cost of all the different departments and functions that do that today, right, from sweeping the streets to snow removal to local rural power to repainting the lane markings to repaving the road. All of those are benefits that they claim. In aggregate, the economics probably work. But that's like 10 or 12 different businesses that provide that service today, and to capture that value from the sum total is an incredibly difficult business value proposition. I mean, if you here as an entrepreneur in Silicon Valley, you get told build one business first before you try to get all the other value propositions that can create, because you got to make one work. So my view is it's a great.
Here's a question then, just to build on Hunter's thought. Would it work when you're building a city in China, when we're building a new city, a new big city every month in China, and you're starting from scratch? Would it work there where you have a central government making what decisions? Are you bullish enough on the technology? Like, I'm a little nervous about the technology. Yeah. But you seem to be.
My view is it's great as an application for denser spaces, so parking lots that really are, where you have lots of snow removal. Yeah. Very busy places where the fact that I've got more power and I have congestion issues already, then it makes sense to me. Will we really, and the video sort of makes it seem like we're going to redo our interstate highway system. I think that's pretty unlikely because of the scale and the fact that a lot of that is quite remote. China is another example. I mean, China's building a couple hundred cities over the next 20 years. Essentially,
the roads are so congested they would never be able to charge. I just found the flaw there, sorry.
There you go.
All right, other questions?
Yeah.
Yeah.
Hi, I'm Ripu Malhotra from SRI International. wanted some clarification. I thought I heard you, and I may have misheard you, so please correct me if I did. When we were talking about the efficiency of cars and talking about only 1 out of the $55 that you put in the car, so kind of 2% efficiency or less, something like that. And then you compared it to electric, which went all the way to 85% efficiency. Is that correct? I mean, did I hear that right?
So I said the drivetrain goes to 85%. The 1% is a combination of the internal combustion engine, which has about 30% efficiency, plus then all the aerodynamic losses, the heavier weight that you have. So if you could do an electric car,
it's apples to oranges.
It's apples to oranges. That's
okay.
right, because you're going from 30 to 85. But what people hadn't realized until Tesla came out is when you really re-engineer the car from the ground up to be electric, you wind up getting savings in all the other areas too, right? The whole car becomes lighter, your layout becomes better, the aerodynamic performance gets better because you have more flexibility. So the final savings won't be 1 to 85, but it'll still be a very significant change. And the whole argument of industrial revolutions is I just need 1 order of magnitude change, right? 10 or 15x increase, and I'm there. So the 4% to 60% utilization is 15 times, that works. I think in the drivetrain, we'll go from 1% net efficiency to somewhere 30, 40% total system efficiency, and that's already the same kind of magnitude change that we need. But you're right, the 1 to 85 is apples and orange comparison, so 2 different statistics. Another one on your right?
I'm Ray Martin with Sustainable Silicon Valley. I appreciated your comments about the autonomous guided vehicles and the opportunity for increased density. You talked about an 8x increase in density of vehicles through a particular thoroughfare. Can you talk a little bit about your vision of the transition to autonomous guided vehicles? Yeah. Because clearly you have to mix and match for a while, or do you? Right. How does that work?
Yeah, so it's actually not as difficult as you might initially imagine. For one is you can imagine deploying it the way Google is now advocating at the sort of local city level, right? So you do the 25 miles per hour local commuter. And the benefit of that is you get immediate savings in that region, but you also get access enabled to a population that doesn't drive. I mean, they have another great video showing a blind person riding in the autonomous car, right? And being very excited about the experience. So that's one model, which is you could take a campus or this campus or a corporate campus. Another is actually blended into the infrastructure because the vehicles can be autonomous with other human-driven vehicles. That's been one of the challenges to actually building these systems is you have to deal with the real environment with bikers, pedestrians, kids playing on the road, right? So they are designed to deal with those challenges and to be mixed in. You don't get the dramatic density increase in that case because you still have to have safety distances that work for the human drivers who have to react. But I think one of the best examples that we kind of pioneered in California was the high occupancy lanes. We've used that to promote electric vehicles, hybrid vehicles first and now electric vehicles. And you could run the same play with autonomous vehicles. You could say that's now an autonomous lane. And the speed limit is higher there, and the density is higher there, and so you see these cars zooming by, and you can only get on if you have the relevant electronic systems, not if you're a human driver, right? So that would provide a sort of bridge path. Another example would be regions, whether it's Singapore deciding that you had to be all autonomous for a core, or London downtown, or a new Chinese city. So I think we'll begin to see pilots like that in particular geographies. But there's a benefit in fuel efficiency just from having a computer drive the car because they can taper the acceleration and the performance to what's the next traffic light, what's the speed ahead. And if you get really good with your Prius and you're watching that energy meter all the time, you can get 15, 20% fuel efficiency improvement, except it takes a lot of focus. You're watching that screen all the time. And so in an autonomous car, you get that for free.
I read an article written by a technology reporter a couple of weeks ago who was riding in one of the Google cars through Mountain View, and there were two driverless cars, and one went into an intersection, and so the second car that the reporter was in went right into the intersection. The light turned yellow. They were turning left, right? So the light turned yellow. So the first driverless car turned left on the yellow light, and the second car. Here was the big question. The light was they were already in the intersection, the light was gonna turn red. What was the driverless car gonna do? And the reporter's sitting there going, and he went through it. He went through the red light, but which is what he was supposed to do. But it was like one of these things where, what is gonna happen here? And so then the reporter having survived this experience, went back and looked up through the records, have the driverless cars gotten any traffic tickets? Not yet. Another question. Okay, so I have one, if we're waiting for somebody else to come up with a question. My question for you is, you've consulted, again, for so many big companies around the world. Do you think the big companies, what's it going to take for some of the big companies to seize these opportunities and change and take advantage of them? Or, as Clayton Christensen has told us, this is going to signal the demise of some of the big companies. We talked a little bit earlier about, I mean, Steve Chu talked about Ralph Cavanagh. Can the oil companies change? Can they adapt? There was Steve Chu said, well, yes, they ought to be able to. And Ralph said, well, we're not seeing a lot of evidence of it, but I hope so. It's a good example, right? What, from your experience as a big company management consultant?
I think it's going to be mixed, right? You see big companies that are moving very significantly. You see some that are doing it under dire distress from a new Silicon Valley startup in some cases that is putting them under pressure, or a government mandate, right? I mean, it's interesting, you know, when Europe introduced carbon standards, or when we introduced CAFE standards in the US for transport, suddenly all these car companies dramatically increased the efficiency of their engines. It's not as if they invented a new technology, right? That potential was always there, but it took a government intervention. If you look at why does BMW suddenly have the i3 electric car and the i8 carbon fiber hybrid, it's because their dealers here started losing massive market share to Tesla, right? And the dealers were screaming and going, we're going to go bankrupt if you don't give us a product that can compete with the Tesla.
Although there's a story on that, there's a regulatory bad story on that, is that the i3 BMWs are stuck in a parking lot in New Jersey right now because they don't know how to score them in their miles per gallon rating with the EPA label or whatever that comes in the windows. So the EPA is still trying to figure out the methodology. So the cars are in America, they're just not in California yet.
Somebody help them with the math.
That's right.
Yeah.
All righty.
I have a question.
Oh, yes.
So Judith Schwartz, to the point. So I think in this discussion, which is exciting and interesting, it seems to me that things about human nature are missing. So when you talk about the amount of time you're in your vehicle or the energy efficiency, I really don't think people buy Teslas because of the energy efficiency.
Absolutely right.
I think they buy it because it's the most sexy car in the universe. And people don't buy a Nest thermostat because it's the best thermostat. They buy it because it's an object of desire. And I don't think Tiffany's would sell all the jewelry they do based on how much time it's on your arm. So I think that you're kind of leaving out the human factors piece that, you know, lots of companies spend a lot of time on marketing and things like that. And could you sort of maybe put your comments in a context of larger framework of human interests and desires and motivation?
I mean, I would just say you're absolutely right. Human behavior and the desires we have and what delights a customer is an absolutely central part. So we didn't talk about it, but in the advice for what a company does, which is in the sort of second half of the book after laying out these challenges, you cannot lead with the energy efficiency, right? If you ask people, are you willing to pay a premium for green? In the US, you get about 15% of the population that says they will. If you actually look at what they buy, you get somewhere between 1% and 3% of the population that actually buys green premium, right? So the successful models all lead with it's more convenient, it's more sexy, it's faster, it's a cool status symbol, it'll make your life easier, right? And that's why people buy it. So I completely agree. And I think the positioning of a lot of efficiency products and a lot of environmental products has been completely wrong, has been touting the savings or the environmental benefit rather than touting the immediate consumer benefit. And we need to get a lot more marketing and behavioral expertise in to really make that effective.
When you read the coverage of the CEO of this Chinese prefab high-rise construction guy, he talks about gorgeous buildings that are wonderful to live and work in, that feel really nice.
Earthquake safer.
They're earthquake
9.0
safer.
Earthquake.
And then, by the way, he says, and the running costs are lower because it's energy efficient. Right. I mean, so absolutely. I mean, I'm totally on your team with that one, Judith. Absolutely.
It's interesting you gave the example of Tiffany, right? If you look at gold, recycled gold is actually much cheaper than new gold mined, but nobody wants to have recycled gold in their wedding ring, so Tiffany hasn't made that change. There are people that like to drive, although that one I will tell you is a generational and cultural shift that is already in progress.
Well, it's interesting that so Judith said that people like to drive, particularly German men. Yeah. The German car companies are having, they're launching their driverless functionality. Because again, there's a gradation. So like the lane assist sort of warning signals and everything else. That's on the continuum to total autonomy. Those features are not as utilized or sought after in Germany amongst male car purchasers as they are in other places.
I have to tell a funny story on that one because the navigation systems all have a human voice now, right? And in most of the world, the default is a female voice because both men and women like that better. German car drivers hated the navigation systems because they didn't want to take orders from a woman.
All righty. Well, I thank you. This has been really, really fun. I hope you enjoyed it, and we'll look forward to the afternoon.